Let's look at this problem. We have two situations. In each situation, we have a box with given weight and an external force applied on it with a given direction. And we are also given the coefficient of static friction and the coefficient of kinetic friction between the box and the contacting surface. And in each situation, we need to determine what the friction force is. So the problems are really basic and also similar. So let me start with the first one on the left. So we always start with a correct free body diagram, just like doing any other problems in statics up to this point. So we have weight force. Normally, if it's not specified, we assume the box is uniform. Therefore, the weight force is right here at the center of 200 Newton. The applied 500 Newton force can be resolved into horizontal and vertical components. Horizontal component will be 500 times 4 over 5. That'll be 400 Newton here. And the vertical component will be 300 Newton. And of course, we have a normal force. The location of the normal force at this point is unknown. And also we have the frictional force. So now we have completed the free body diagram. And in this case, we have actually two unknowns, the normal force and the frictional force. So the resultant force along the y direction has to be 0 because there's no movement along the vertical direction. So that equals to normal force minus 200 Newton weight, also minus the 300 force, this one right here. And that equals to 0. So from here, we can solve for the normal force to be 500 Newton. So at this point, we're going to assume box is not moving, because when the box is not moving, the static situation, statics equilibrium equations applies. Therefore, we can write this equation: resultant force along the x direction equals to 400 Newton minus the frictional force equals to 0. So from here, we can solve for the frictional force to be 400 Newton. However, don't forget, this is an assumption, and we have to evaluate to see if it's actually a valid assumption. So how do we know that? We know that the maximum static friction that could occur between this box and the surface is determined by the equation mu s n. So mu s times n equals to the maximum static friction. So before static friction reaches this limiting maximum value, static friction is always determined by equilibrium because we can apply static equilibrium equations. But after the static friction has reached this maximum limiting value, this is when the box is about to start sliding. It's about to move. Therefore, we can calculate this. The maximum static friction equals to mu Sn. Mu S equals to 0.3, N equals to 500, and that equals to 150 Newton. Therefore, we realize that the calculated 400 Newton is bigger than the maximum static friction, which is 150 Newton. So what does that tell us? It tells us that the answer to this question, is it valid? Is the assumption valid? The answer is no. The assumption is not valid. Therefore, this is incorrect assumption. Therefore, the opposite is the box is moving. It's actually sliding. So if the box is sliding, we have kinetic friction instead of static friction. And kinetic friction is always calculated by mu kn, which equals to 0.2 times our normal force, 500 Newton, to be 100 Newton. And that's our final answer for this part. The frictional force is 100 Newton and it's kinetic friction. And the box is indeed sliding. So the second problem over here is very similar. So I'm going to do it really fast. We start with free body diagram. We have weight force, only 40 Newton. 100 Newton applied force is resolved into a horizontal 80 Newton force and a vertical 60 Newton force. Again, we have a normal force with unspecified location. And we also have frictional force. Right now, we don't know if it's static friction or kinetic friction. However, along the vertical direction, resultant force is indeed 0, and that equals to N minus 40, that's the weight, minus is the 60 applied force, equals to 0. So from here, normal force is 100 Newton. So similarly, we're going to again assume not moving. Statics equations apply, therefore resultant force along the x direction is also 0, and that equals to 80 Newton minus FF. So from there, we can solve for the frictional force to be 80 Newton. So again, the question is this assumption a valid assumption or not? How do we know? Again, we compare this with mu Sn, because once again, that is the maximum possible static friction between this box and the surface. Mu Sn, mu S in this case is 0.9, normal force is 100, that is 90 Newton. So as you can see, our calculated 80 Newton is actually smaller than the maximum static friction. Therefore, this tells us that the assumption is indeed valid. So, valid assumption. The box is not moving. And we have static frictional force. And that equals to 80 Newton as we determined. So these two examples are two very basic examples for us to get familiar with the conditions when we solve for frictional force.